Hi guys, today we're going to be looking at a question on organic molecules. Question 2.1. The IUPAC name of an organic compound is 4,4-dimethylpentene. Question 2.1.1. Write down the general formula of the homologous series to which the compound belongs. So as we can see, the main functional group is pentuene. Therefore, it is an alkene, and an alkene has the general formula CnH2n-2. The -2 is due to the triple bonds that are present in this organic compound. Question 2.1.2. Write down the structural formula of this compound. So as we know, we have pentuene, which means we have 5 carbon atoms, and between the second and third carbon, we have a triple bond for the pentuene. On the fourth carbon, we also have 2 methyl groups, this being the fourth carbon, and then from there, we just fill the rest of the spots with hydrogens. Question 2.2. The organic compound below has 1 positional isomer and 1 functional isomer. Question 2.2.1. Define the term positional isomer. A positional isomer is a compound that has the same molecular formula but has different positions of the side chain or the functional group on the parent chain. For this compound, write down the question 2.2.2 IUPAC name of its positional isomer. So as we can see here, we have 5 carbon atoms and a double bond to the O atom on the second carbon. Therefore, this is pentan-2-one, as it is a ketone. The positional isomer of this would be putting the functional group on the third carbon, because we can't put it on the first carbon, as that would make it an aldehyde and not a ketone. So our answer would be pentan-3-one. Question 2.2.3. Write down the structural formula of its functional isomer. So in this case, we would put the double bonded O on either the first or the last carbon atom, as that would make it an aldehyde. Therefore, keeping the molecular formula the same, but just changing the functional group. And if we draw that, we should get 5 carbon atoms, a double bond to the O, and the remaining spots will just be filled with H's, hydrogen atoms. I'm going to do question 3 on a new page, so there's more space. Question 2.3. Consider the condensed structural formula of an organic compound below. Question 2.3.1. Is this a primary, secondary, or tertiary alcohol? Give a reason for your answer. So as we can see, the OH group is connected to this carbon atom over here, and this carbon atom is connected to 3 other carbon atoms, being this one in brackets, showing that it's a side chain, and this one over here. Therefore, this is a tertiary alcohol, as the carbon atom that is bonded to the functional group, being the OH, is also bonded to 3 other carbon atoms. Question 2.3.2. Write down the IUPAC name of the above compound. So, as we can see, since we have an OH group, this is an alcohol. We have 1, 2, 3, 4, 5 carbon atoms. However, the one in brackets, let me just remove the circle. The one in brackets shows that side chain, which means on the main chain we have 1, 2, 3, 4 carbon atoms. And since it is an alcohol, it is therefore, and the OH group is bonded, if we count from the lower side, this being the first carbon, the second carbon, the third one, the fourth one. The OH group is bonded to the second carbon. So we have butan-2-ol. However, we still do have this side chain over here, being a methyl group, which is also bonded to the second carbon, making our name 2-methyl-butan-2-ol. Question 2.3.3. Write down the IUPAC name of the major organic product formed when this compound undergoes an elimination reaction. So when this compound undergoes an elimination reaction, this OH group as well as an H will be removed, as a water molecule will be removed from the alcohol. And when this water molecule is removed, we will then be left with 2-methyl-butene. As due to getting rid of this OH as well as a H molecule, we then have to form a double bond in order to fill all 4 bonds between the C atom. So we would be left with 2-methyl-butene. And that's all for this video. Thank you.